Our first talk will be held by Leon. Leon is working at Eurofiber Netze. Sadly, his co-presenter Julia fell sick, so the show is totally up to you. He will talk about the elephant in the room, about building a custom shelter to find a new home for your elephant. Have fun.
Thank you. So as Nico said, thanks for this introduction. My name is Leon. I work in the network engineering team at Eurofiber's Berlin business. Unfortunately, my colleague Julia has been hit by a fever over the weekend. So I will have to do a bit of PowerPoint karaoke, but it will be fine. She's let me in on some of the secrets. Eurofiber has been building a fiber network, or is in the process of building a fiber network in the last couple of years in Berlin. And as you can see on the slides, Eurofiber's elephant has been rather enjoying this adventure. However, at the end of the day, the elephant is tired and exhausted, and it was looking for some shelter. Now, as we're all network engineers, the only thing that we could come up with was that thing. So it basically looks like your typical street cabinet that is used for housing network devices. And on a more serious note, so this is a custom street cabinet for network devices that we have designed, and we thought it might be a fitting start for the conference to let you in on some of the thoughts that need to go in the layer one, the basic infrastructure for network engineering. What's all this nonsense about an elephant? So this company started as an idea of Vattenfall in Berlin, the big energy provider. They used to own and operate the district heating system. In German, it's called the Fernwärmenetz. So it's basically lots of underground tunnels that have these big isolated pipes in them full of hot water to bring heat into households. And Eurofiber thought about why not capitalize on that. Vattenfall thought about this. And used it for running fiber through the streets. So it basically saves a lot of digging, and it could be easier, and they could just use those little robots, as you can see on the bottom picture, to pull fiber through the already existing tunnels. To start this project, they looked at an investor. They looked for investors and found Eurofiber, who were willing to join, bringing along lots of experiences with fiber networks from Belgium and the Netherlands. And most importantly, of course, they brought along their mascot, which is the elephant. Some years have passed since then, and today we're owned 100% by Eurofiber, so no longer associated with Vattenfall. The business model still is the same, though. It's an open access network only, which means we collect the traffic from the households that are distributed everywhere in Berlin and move it to central points in the data centers, which is where the ISPs are. So the ISPs are our customers, and we need to move the traffic from households to traditional ISPs, and we basically rent out the last mile as a fiber network to them. So that means we need a network to collect all this traffic and need some aggregation points somewhere. But where to put those? So in a city as densely populated as Berlin, building ground is always very difficult to obtain, especially in the streets. So the thought came up to us to talk to Vattenfall, which were still our mother company back then. They owned and operate all the combined heating and power plant sites in Berlin. However, it turned out that we couldn't put our equipment in the buildings there for various restrictions. But they do also have a lot of outdoor areas. So for example, on this picture, you can see this patch of grass over there. They were like, yeah, you can put your routers there. Well, great. But that means we need an outdoor solution. So we turned to the market. And what we found were the traditional street cabinets, the ones you can see on the left-hand side. They're like half a meter deep. Problem with those is they don't fit your typical metro Ethernet router that really wants to operate in a data center-like environment. It needs a full depth rack. It needs to be air conditioned and stuff like that. So the next bigger thing that we found were those concrete containers that you can get. They're quite luxurious, really nice. So you can get them with a raised floor, with full-sized racks, with air conditioning already. The trouble with those is for most of our applications, they were too large, and we would never be able to fill all the space, and then it's just a bigger investment than we could justify. So really, we were looking for this middle ground, something in between. And as we also needed not 1, but 15 of those POPs just to cover our area and the footprint, the idea came up to have a special design, because with a quantity of 15, this is where it makes sense. We basically were looking for a small data center, but less expensive than an actual data center. And this is the end result. So the end result we're talking about here is a 3 by 1 meter outdoor cabinet with air conditioning. And yeah, in the following presentation, we want to shed some light on the process. How did we get there? What thoughts go into a process like this? So as with any good project, the step 1, of course, is collecting requirements. Some of them are really basic. Obviously, it needs to be rainproof, windproof, and dustproof, because that's what your router's like. But then, of course, it needs to be large enough to actually fit all the devices, which means, you need to think about what sort of devices do you have. What we really wanted to have was front and rear access to the devices, because it makes everything more convenient if you can easily work on the power cables and the network cables from both the front and the rear. Of course, they needed to have redundant power supply system, air conditioning, because the typical Metro Ethernet router doesn't really want to go above 55 degrees Celsius. And another thing that we really wanted was to stay with a footprint to stay below 10 square meters, because this is in Berlin the threshold. If you stay below 10 square meters, you don't need to get a permit for your construction. And the last thing you want when putting up 15 cabinets is to get a building permit for each and every one of those, because this delays everything and makes it more expensive. And of course, the investment should stay manageable, because we don't. Well, who wants to pay more than you need? With these thoughts, we started a design process, and we immediately hit a problem, because we were building a greenfield network. It was a completely new network, which is very nice. However, there's a lot of unknowns there. So we were starting to dimension the housing for the devices, but we didn't even know which devices we would choose yet. So that's a problem, because then you don't know that your power requirements, you don't know the heat emissions of your devices, and how to get around this. So what we did is, of course, we made some educated guesses to break this dependency, made some assumptions. And then you just estimate generously. You have to leave some headroom for the unknowns and for when your business model might change in the future. So basically, we put in some dummy devices. So we had a quick look at the market, like the three usual suspects of Metro Ethernet router vendors, checked what they offer, and then you basically put in some candidate and take the largest device with the most heat emissions, and then use that for making estimations. Here's the brief layout that we chose. So we decided to split it into 3 racks. On the left-hand side, the blue rack is the ODF PON rack, which is where all the fibers coming in from the households. And on the rear side, we have the fibers leaving towards the backhaul network. And conveniently located right next to that in the middle rack is where we're putting the OLT. So those are the active devices. We are patching just with a short patch cable to the ODF PON rack. And on the right-hand side, we needed some transport routers, DWM equipment, and an AC-DC converter, because we wanted the whole thing to be battery buffered. And then it's easiest to have all the devices run on 48-volt DC power. On the rightmost side, that's where the air conditioning units are living. So as we didn't have a lot of experience with that sort of stuff, we turned to manufacturers who did. So all the physical, the weather requirements, this is what they're really good at, because they are actually building such cases every day. And they recommended to us to perform a thorough thermal simulation of the case. And these are some of the assumptions that we put in. So we assumed in summer it might get 40 degrees of Celsius at max, plus an additional component coming from the solar radiation on the case. And with this, we wanted to have the inside air temperature stay below 55 degrees. As I mentioned, the devices that are shown here, these are dummy devices. Most of those aren't the devices that we actually ended up using, but we needed some assumption for the heat calculations. However, what happened then during the process was that in a different project, we were then ready to actually choose the model of the OLTs, the ones in the middle rack. And as we had chosen those, we learned that they are capable to operate up to a temperature of 65 degrees. Which helped because we could actually separate the cabinet into two compartments and only air condition one of the compartments. So as you can see on the left picture here, the right compartment, the compartment on the right-hand side is air conditioned and stays below 40 degrees of Celsius. And the bigger compartment on the left containing the OLTs and the patch panels, they don't care. They stay below 65 degrees just by passive ventilation of air and exchanging it with the outside. So this heat simulation was really useful for us because it confirmed that we could actually have smaller air conditioning units which consume less power by only air conditioning one of the compartments. And on the right-hand side, we also got from this engineering company that ran the simulation for us, we also got a airflow velocity simulation. So what you can see there, the arrows represent the airflow direction in the cabinet, and the colors represent the airflow velocity. And that was really useful to make sure that the air exhaust of one device would not end up directly at the air intake of the other device, which would be bad. And we could also optimize the airflow a bit by putting a metal sheet here and there to redirect air. So that was really useful, and we definitely recommend you do that. Another thing that we recommend is to also perform a noise emissions simulation. Because my colleague Julia, she tells me that there's rather strict regulations in Germany on the amount of noise levels that you can emit. So with this, we had a design ready that we could give to manufacturers and basically press the play button to have them build all the cases for us. And of course, this is a step in the project where when you start to notice all the things that you didn't think about. So your design might be very nice on paper, but then when it's actually time to deploy it on the building ground, on the heat plant sites, that's when you're hit by other problems. For example, we've had some very German problems, I would say. So in Germany, there's this thing called Denkmalschutz, which is basically monument protection law. So a building can be listed and be protected, so you're not allowed to change the overall appearance. So we're not allowed to put our modern-looking street cabinet out there because it would change the appearance. And what do you do about that? Basically means your cabinet needs to be invisible. And how to make a cabinet invisible? Can anyone spot our cabinet in this picture? How about this angle? So in this case, the solution was really easy, and sometimes you have to be creative, right? The solution was just to spray paint a brick facade pattern onto the case, and that worked. Other problems that you immediately notice when working with a company as large as Vattenfall is there's lots of different stakeholders in a company like that. So it is one thing if the business strategy department of Vattenfall has devised this funny little fiber network project. But when it's actually about going out there and talking to the crews on site and getting permission to build something, it's an entirely different thing if the people on site are motivated. And we learned that this can delay getting approvals and finding an actual location for your cabinets. But our takeaway there was that, as often in life, it's best to take the constructive approach. Cooperate with the people, work with them, try to motivate them. Don't try to work against them, even though, yes, technically you do have approval from the bosses of their boss to do what you want to do. But it helps if you can get the people on board. Or some other problems that we've had is on one of the heat plant sites, the only place we could find for our cabinet was located on the middle of some disused rails, which is inconvenient. You can see it on the picture on the bottom here. We've actually had to design a custom base foundation, so an even more custom project for an already custom cabinet that would actually fit around the rails there, so we could leave those in place. And some very basic problems. We noticed that it is cold in winter, in fact. And that tends to delay your construction work. So all the groundworks you need to do, you obviously can't do that when the ground is frozen. Splicing work tends to take longer in winter because the splicing people have to take breaks because their fingers are freezing and stuff like that. So you should definitely keep that into account. Once we had the cabinets in place, it was time to actually put equipment in there, and we noticed some other problems, smaller things. Now we had thought we had already done the smart thing, and next to the 48-volt DC power supply system, we added as a convenience a single 230-volt power socket, so you can charge your laptop or bring a light when it's dark. Obviously, as it is cold in winter, the first thing the splicing company does when they notice your nice little power outlet is attach their 3 kilowatt fan heater. And obviously that immediately blew the circuit breaker. So we've learned the hard way that we have to add a proper power outlet. Other trivial things, we noticed that one of the middle doors was designed in a way it could not be opened by one person alone, because you have to pull 6 spring-loaded pins at once, which is a problem because most people only have 2 hands. So the manufacturer actually designed another locking mechanism for us. And the manufacturer actually was really interested in feedback. They were actively asking for this. And we've actually heard that by now they are also showing around this cabinet on trade fairs and offering that as a standard product in their portfolio. So it was nice for them as well. It was a good cooperation. One last thing that might be entertaining is we thought, we actually did have a very redundant power setup. So firstly, of course, we have the main commercial power coming in on one feed. But we also had, as a second feed, another power feed coming in from the neighboring cabinet, because we always put those in pairs of 2 on each heat plant site for redundancy. So if our power would fail, then our neighboring cabinet could still supply us. And if both should fail, then we still have a battery buffer to run on for a couple of hours. To switch between the 2 power feeds, there's an automatic switch control module, which is very clever and notices when one power fails and switches to the other, and that works fine. That's basically 3 ways of getting power, and those would never fail at the same time, right? Well, I still think it's a fair assumption. But in reality, power failures, of course, they do occur. For example, in Berlin, I would say at least once a year there's an arson attack on power lines. And in one of those cases, we had the problem that the neighboring power feed from the other cabinet, that was not available yet because it was still being constructed. So then we were running on the batteries. And of course, they ran out after a couple of hours, which was bad. But the cabinet is sitting there dark and silent, and there's not a lot we can do. So at least it should come back on, right, when commercial power is restored. Well, that's when we noticed that that control switch that needs power coming in from the UPS, but the UPS has switched off because the batteries are below 10% to protect them. And the UPS is not coming back on because it would need power from the control switch, and the control switch needs power from the UPS. And yeah, we basically noticed a cyclic dependency in our power design, which meant that the cabinets were not cold start capable, which is a design flaw that we had to fix later on. Well, thankfully, we've noticed this rather early in the project when there were not a lot of customers connected to the network yet. But now at least that is fixed. So should the situation ever occur again, then at least we have a way out of that. And our field service people can go there, and there's a manual switch now to override the power routing and bring the control switch back on. So that's the stuff that you learn. To summarize, what else have we learned? Building a custom micro data center, basically, it turned out it is feasible, and even without large investments, so you don't need to get the concrete containers. It didn't even take too long. Design and prototyping took us about 6 months. Obviously, some things didn't end up working as well as we thought, but I think those are minor changes that we had to make, and some adjustments are always unavoidable. So there's no way you can think of every little detail when designing a thing on paper. Ideally, the things that you forget, they are fixable later, and in our case, they were. It also turned out it was a good idea to stay below the size that requires getting a building permit. Because for some other applications, we actually did get a few of the concrete containers. Yeah, that took a while. That delayed everything, and it was annoying to get the permits. And you definitely should allow plenty of time for construction, politics, and social dynamics when building a project like this, especially when dealing with large companies. But the takeaway here is definitely a positive note. If you're creative, you can find a solution for almost everything. So even if your cabinet needs to go on some railway tracks, or if you have monument protection laws, as you can see, sometimes the solution is really simple. That's it from my side. Do you have any questions?
Thank you. Thank you. Thank you, Leon, for your talk. Are there any questions? Yes. We should have a microphone walking around, don't we? Do we? Okay. I'll just come over to you. Please state your name and your affiliation before your question.
My name is Dirk Meyer, Netcom Kassel, and I like to ask: Did you need any power protection against oversurge or anything?
I think this is built in the UPS system that we have acquired. So it's a standard UPS system that you can get on the market, and I think they take care of stuff like this.
Thank you.
Sebastian Schrader, TU Dresden. Did the spray paint mess up your heat simulation due to...
Excellent question.
Because the solar characteristics would change if it's not white anymore.
Excellent question. Yes, it did. So we actually, we have temperature graphs, and this spray painted cabinet is consistently above the other cabinets. So yes, we have to see if we have to adjust the air conditioning units when it's coming to next summer. But yes, that did affect the heat calculation.
Are there more questions? Yes.
Hi, Alexander Fotteler, Relax Networks. You have talked about different maximum heats for both compartments. Is there also some issues with too low temperatures? Because we have in our MFGs, we have heating for really cold days. Do those devices need heating?
We actually do have a heating system in there, yes. So because you don't want to have them operate underneath a given threshold, yes. So there's both an air conditioning unit in there and a heating system. This is stuff that we could get from the manufacturers, and they recommended stuff like this to us. So.
Hello, Philip from Benox, Philip Urbanik. Question, how much time would you plan for the next time for politics and so on? Because you said just plenty, but what is plenty?
Twice the time that you would think it might take. So I don't know. It depends on your project. It depends on your company. It depends on your project managers. Just keep it in mind is my message here. Don't think everything should go quickly just because the large company has decided to do this project. There's still different people inside this company.
Hi, Gordon Guido for the Unaffiliated. I wanted to ask, this design project, did you do this as a network engineer, or did you bring in specialized engineers who specialize in designing cabinets such as these?
So this was done partly within our team, and then we also we got external expertise. For example, the heat simulation that was performed by an engineering company. The manufacturers gave a lot of input, as I said. Our main job was basically just to think about the equipment that we want to put in there. Where do we want to have each rack? What happens with the cable routing? You won't avoid that sheet of spaghetti that might end up in a couple of years there, but how could we manage that a bit? And then obviously for deploying the stuff, we had some professional project managers. This is so it was partly within our team, partly external.
So, no more questions? No? Well then, thank you, Leon, for your talk.
Thank you.